Alright everyone, this is going to be the last lesson for the first unit. So please make sure you have this to me 2 days before the unit test, the last day to turn in late work. Last time we talked about direct variation, and this time we're going to talk about inverse variation. So sometimes keeping in mind in your head what direct variation was will help you remember what inverse variation is. Let's see, inverse variation, we're going to do table, graph, equation. We can start off with the equation. Okay. And the equation for inverse variation, you can write it in two ways, is going to be y equals k over x. And I'll put the k is the constant of variation. I'll put it over there, but remember we learned this last time, but please ask me in class if you need help with it. K is the constant of variation. Or you can rewrite that if we multiply both sides by x of this equation. If you multiply it on both sides, x's cancel out on the right, and it's y times x equals k. So remember last time in direct variation, every time you had y and you divided it by x, you got your constant of variation. For inverse variation, every time you multiply y and x, you're going to have k. So that'll look familiar when we do our example for the table. If we draw a table and make up some numbers here for you, double check my numbers. I think I missed a number on the table in the last video. So please make sure and hold me accountable to having all of the correct answers here. So the table, x, y, 1, 2, let's just do x, 1, 2, 3, 4, 5, 6. And let's see, these are the numbers I have here. 3, 1.5, 1, 0.75, 0.6, and 0.5. Okay, so the first really important thing to realize about the table, and we'll see it what shows up in the graph, is that as x is increasing, right, x is 1, 2, 3, 4, 5, 6, those numbers are getting bigger. The y values are decreasing. Y starts off at 3, but then it's only half, and then it's only 1, and then 3/4 or 0.75. So it's always going to be this way. As x is increasing, y is going to be decreasing. And then let's just make sure a regular direct variation can do that too. So let's just make sure, what's the other thing we need to check? We need to check that x times y is always going to give us a constant, is always going to give us the same value. So let's pull our table down one more. And here in this last one, in this last row, we're going to do x times y. So 1 times 3 is 3. 2 times 1.5 is also 3. 3 times 1 is also 3. And then trust me, or don't trust me, check on your calculator. The next are also going to be 3. So my k for this particular table, x times y, is going to be 3. So if you're given a table and you're told to make an equation from an inverse variation, then you can multiply the x and the y, get your k, and throw it back into the equation. So the equation up here at the top is going to be, if we were going to make an equation using that formula, y equals 3 over x. And that's going to be the equation for this particular table. Now let's look at a graph or a model, graphical model. So this is what it's always going to look like, just like a dog is always going to look a certain way, or a person, or a pencil. This is always the way an inverse variation is going to look on a graph. So let me draw it out here. Three, four, five, six. This is my x, my y, my origin. And then my y's only go up to 3. So this would be 1.5, 0.75. Oops, sorry, see, gotta keep an eye on me. 1, 2, 3. Oops, no, look, I'm doing it again. This is just going to be 0.5, right? 0.5, 1, 1.5, 2, 2.5. There we go. That's better. You got to make sure you have a good scale there. When x, let's plot our points. When x is 1, y is 3. When x is 2, y is 1.5. Oops, let me put my x here. Three is 1. 4.75. It's going to be a little bit more than half, right? 5 is going to be 0.6, or I'm sorry, 5 is going to be 0.6, yep. And 6 is going to be 0.5. Okay, so my y starts off big and gets smaller. It starts off up and starts to get smaller as my x is getting bigger, and your graph is always going to look curved like this, okay? So let's throw this under the reminder. It's always curved, okay? And what are some other things that this graph is always going to look like? This is interesting. This graph is never going to cross either axis, okay? It's never cross either axis. So what does that mean? That means it's never going to cross the y, it's not going to have a y-intercept, and it's never going to cross the x. It's always going to be kind of in the middle there, and it's always going to be curved. Okay. And just remember that while we're going through the practice problems, the table, the equation, and the graph to represent the inverse variation. When I see you in class, make sure you have the summary part saved so we have room to write that. I will be asking you, how can you tell if an equation is an inverse variation? How can you tell if a table is an inverse variation? And how can you tell if a graph is an inverse variation?